This is a continuation of the test number 1 review questions. This video will cover questions 7 through 10. So let's begin. Number 7 says multiply and simplify, and you have a rational expression times a rational expression. To multiply rational expressions, we normally multiply the numerators and multiply the denominators. But it really helps us if we try to simplify it first. So I would actually write this as simplify and multiply. So to simplify, I need to factor all of the pieces in the rational expression. So if I begin with the first rational expression in the numerator, I notice that 3x minus 6 has a common factor of 3. So I factor it out and I'm left with x minus 2. In the denominator, I have a trinomial, and I'm pretty sure it'll factor. So I need to find a pair of numbers that will multiply to 6, but then add to 5. So I can use 3 and 2, and they're both going to be positive, times the second rational expression, x squared minus 9, is a difference of 2 squares. So I know it factors x plus 3, x minus 3. And the denominator is also a difference of 2 squares. And it factors x plus 2, x minus 2. And then we're going to use a process. It's not really a math term, but I call it simplifying on the bow tie, because I can simplify anything that is diagonally across from one another or that is on top of one another, so that it looks like I'm simplifying and it creates a bow tie. So if I'll do that, I notice that in the numerator I have x minus 2. In the denominator I also have x minus 2. In the denominator I have x plus 3. And in the numerator, I have x plus 3. So those things will divide out. So I'm left with 3 times the quantity x minus 3 over x plus 2 times x plus 2. And I can simplify that particular result a little bit so that I end up with 3 times x minus 3 over x plus 2 squared. Okay, because there's two of them. And that's an acceptable way to write the answer. All right, number 8 says, what are the critical numbers for the inequality x cubed minus 2x squared minus 3x less than 0? Okay, the critical numbers, the way to find the critical numbers for an inequality is you set the expression equal to 0 and solve. Okay, so I'm going to take x cubed minus 2x squared minus 3x, and I'm going to set it equal to 0. Then, because it has an exponent of 3, that's a big clue that I'm probably going to need to factor. And I notice that I have an x in common through the entire problem, or the entire expression, so I'm going to factor out 1x. That leaves me with x squared minus 2x minus 3 equals 0. Then I believe I can factor that trinomial down a little bit further, or that quadratic. So I have x, and I'm going to break this apart. I have x and x. I need a pair that multiplies to 3 and subtracts to 2. So that's 3 and 1. The 3 is negative, the 1 is positive, and that equals 0. I then know that one of those pieces, one of those factors, either x equals 0 or x minus 3 equals 0 or x plus 1 equals 0. And then I want to solve each one of those respectively for x. Well, x equals 0 is already solved for x. For the second one, x minus 3, to solve, I'm going to add 3 to either side. So I have x equals 3. And for the last one, x plus 1, I need to subtract 1 from either side to isolate the x. So I have x equals -1. So our three critical values here are 0, +3, and -1. Number 9 asks us to solve a equation. And the first thing I want to do is to eliminate the parentheses. So I'm going to distribute. Okay. So 4 times 3x, 4 times 7 gives me 12x plus 28. That equals 8 minus, and then I need to distribute the minus 5. Be careful, watch your signs. Minus 10x minus 45. Then I'm going to come back and combine like terms. So I have 12x plus 28 equals -10x. I have 8 and minus 45, which will combine together to give us -37. I then need to get the x's together and the constants together. So I'm going to add 10x to either side. So I have 22x plus 28 equals -37. I then need to move the 28, the constant, to the other side. So I'm going to subtract 28 from both sides. So I have 22x equals -65. And then ultimately, to solve for x, I need to undo the multiplication by 22. So I'm going to divide both sides by 22. So ultimately, my answer is x equals -65 over 22. Leaving it as a fraction is acceptable. My fraction does not simplify anymore, so that's the final answer. And then number 10. Number 10 also asks you to solve an equation. And this particular equation is a quadratic. And I recognize it as a quadratic because it has the exponent of 2. Typically, when we solve quadratics, we have two options. We can either factor if the problem is factorable, or we can use the quadratic formula. In either case, whether we're doing factoring or using quadratic formula, the equation itself must be equal to 0 so that you have it in the form ax squared plus bx plus c equals 0. It doesn't specify which process or method to use, so if you wanted to, you could actually use a quadratic formula on this one, but first we need to get it set equal to 0, so I'm going to subtract 10 from either side. So I have 3x squared minus 13x minus 10 equals 0. Now, I'm pretty sure this one will factor, so I'm going to go ahead and try to factor it. I'm using trial and error. There's lots of methods for factoring as well. So I would have 3x times x, and then I need a pair combining together that will multiply to 10 and ultimately subtract to give me 13. So if I do 3x times 5 and 2 times 1x, that gives me 15 minus 2, which would give me the 13. The 5 should be minus, and the 2 should be positive, and that's equal to 0. I then know that one of those factors, either 3x plus 2 equals 0, or x minus 5 equals 0. And I then need to solve each one of those respectively for x. Solving 3x plus 2, I would subtract 2 from either side. So I have 3x equals negative 2. I'm going to divide both sides by 3. So x equals negative 2/3 is one of the solutions. And then I need to finish the problem. I need to do the other factor, x minus x, or x minus 5, excuse me, and I'm going to add 5 to either side. So x equals 5. So the solutions to this problem are x equals 5 and x equals negative 2/3. There'll be a third video to finish out the review, and I'm going to actually add a few things to it that I noticed are on the test that aren't on the review sheet.